In this section, we're going to look at thermochemical equations. Basically, all a thermochemical equation is, it's a chemical reaction in which they have added the delta H at the end of the reaction. So, chemical reaction plus delta H gives you a thermochemical equation. However, what we need to learn how to do is manipulate those thermochemical equations. So the rule is, if you multiply or divide the chemical reaction, then delta H is multiplied or divided according to what you did here. So if I multiply by 2, I would multiply delta H by 2. If I divide by 3, I have to divide by 3. The other rule is, if the reaction is reversed, so the products become the reactants and the reactants become the products, then the sign of delta H is reversed. So if I look here at this example, it's always going to give you one thermochemical equation. In this case, it gave me carbon disulfide plus 3 oxygens goes to form carbon dioxide plus 2 sulfur dioxides with the delta H of a negative 1077 kilojoules. And it wants to know what is the delta H for the following equation. So I can pick any one of these 4 species and look at it. Okay, it doesn't matter. What I want to look at is I want to find carbon dioxide here, if I start with carbon dioxide. And this is the one going from, and this one's the 2. So how did I go from here to here? Well, I want to look at 2 things. The side of the reaction and the coefficient. So looking at carbon dioxide, the coefficient, when there's nothing written here, is assumed to be 1. So I went from 1 to 1/2. Well, I'm sorry, let me go in the order here. Look at the side of the reaction. This is a product. This is a reactant. How do I go from a product to a reactant? I reverse the reaction. So by reversing the reaction, the delta H is, so for this, it's going to be a positive 1077 kilojoules. Okay? And then look at the coefficient. Now I went from a coefficient of 1 to 1/2. How do I change a 1 to a 1/2? I divided by 2. So the 1077 divided by 2 gives me a positive 538.9 kilojoules. And that's the answer to this question. Now, it doesn't matter, as I said at the beginning, it doesn't matter what I do. Okay? So if I look at oxygens, is a little harder because the oxygen has a fraction there. But if I look at carbon disulfide instead, here's carbon disulfide, here's carbon disulfide. Carbon disulfide, it went from a reactant to a product. So therefore, again, it became the positive 1077 kilojoules. And I went from a coefficient of 1 to a coefficient of 1/2. So I also divided by 2. So 1077 divided by 2 still gives me the 538.9 kilojoules. So it does not matter which species I look at. Okay, I'm just comparing from the one in which I'm given the delta H to the one that I'm not given the delta H for. So here's another reaction. I suggest that you can pause this and try doing it first before I walk through it. Okay. All right. Assuming you tried to do that. Let's choose NH3. So I have NH3 there and NH3 there. So for the side of the reaction, it went from a reactant to a product. So it went from a negative 96.2 to a positive 96.2. And no, you don't have to write the positive sign. I'm emphasizing the fact that it changed the sign. All right, and for the coefficient, it went from a 4 to a 1. So therefore how do I go from 4 to 1? I divide by 4. So 96.2 divided by 4 gives me 24.1 kilojoules. And you can round that to 24.0 or 24.1. Okay? And that's basically what we're going to be doing. We're now going to apply this to finding out what the delta H is for a reaction when we couldn't do that reaction, but instead had to do a series of reactions to get there. And that will be in the next